afternoon, and thank you for joining us in conversation today on the hydrogen economy. Welcome, and today we are hosting you jointly as the Academy of Science of South Africa and the Academy of Engineering of South Africa. Firstly, on ASSAf, the Academy of Science of South Africa, we were established in 1996. Again, a call from President Mandela to get the voice of science to lead and develop the nation going forward. So ASSAf has become and grown to become the scientific voice whereby evidence-based scientific leadership is provided both in national and international conversations for the welfare and growth and development of South Africa. I have with me today also the Academy of Engineers, and we are led by the President of the Academy, Mr. T.C. Madikani, and I will hand over to President Madikani to also do a formal welcome from the Academy of Engineers. Over to Mr. Madikani. Thank you.
Thank you, Prof. Naidu. As indicated, my name is T.C. Madikani, the President of the Academy of Engineering. We are pleased to participate in this joint webinar seminar with ASSAf. Maybe let me just give some brief background about the Academy. The South African Academy of Engineering is an independent voluntary engineering association, and its aims and objectives are to promote excellence in the science and the application of engineering for the benefit of South Africa and its people. The Academy was constituted in March 1995 as an autonomous entity with its own constitution along the lines of the academies of engineering in other countries. The Academy currently has 216 fellows representing all engineering disciplines and various sectors. In 2009, the Academy was accepted as a member of CATES. CATES is the International Council of Academies of Engineering and Technology and Science. And as a member of CATES, the Academy takes part in all activities of its CATES. In September this year, CATES meetings are taking place in Brisbane, and the Academy of Engineering will be represented by the leadership. And then the Academy liaises with voluntary associations in various engineering disciplines in South Africa, as well as sister companies around the world to promote dialogue and technology exchange. And it also gives me pleasure to say that on the 14th of April this year, the Academy signed a memorandum of understanding with ASSAf, formalizing a strategic partnership to foster collaboration across science, engineering, and innovation. And I must say that we've been working with ASSAf for more than a decade. And then this MOU, we set as both organizations to say we've got limited resources. How do we maximize our resources between the two academies? The agreement builds on the history, as I've indicated, and it sets the stage to the closer cooperation in advancing the evidence-informed policymaking, promoting interdisciplinary dialogue, and supporting national development goals. And then this MOU, it's got 4 collaboration points. The first one is co-hosting events and dialogues on science and engineering topics. Today's one is a typical one that we are co-hosting, and then producing studies and policy briefs. And then the last one, supporting earlier career professionals and promoting public understanding of science and engineering. And it also involves engaging with national and international science and engineering policy platform. And I also just want to also welcome our panelists and the rest of the individuals that have joined us in this webinar. over to you, Program Director. Thank you.
Thank you, Mr. President. Thank you. Thank you, colleagues. And colleagues, today we'll take a deep dive into hydrogen as a carrier of energy. This hydrogen, we label it green as produced from renewable energy resources. We have a lineup of 4 speakers for you, and I'll introduce each one as they come up. And the 4 speakers emanate from policy, from academia, and from industry. Colleagues, attendees are requested to type your questions and comments in the chat or Q&A tab of the webinar platform. And finally, in terms of the views expressed, they are independent of ASSAf and the Academy of Engineers. So that's our little disclaimer. And but we invite all thoughts and contributions for the proceedings. We'll take an academic view. Professor van der Kerk, please, if you may get ready, and I'll introduce you. Prof. Wikus van der Kerk is the Dean of Engineering at Stellenbosch University. He holds a PhD from the University of California, Berkeley, and an executive MBA from the Graduate School of Business at the University of Cape Town. After completing his PhD, he joined the University of Pretoria as the holder of the Sasol Chair in Vehicle Engineering. He moved to Stellenbosch University in January 2000. He was the founding director of the Center for Renewable and Sustainable Energy Studies and played a leading role in establishing research, education, and training programs in renewable energy. As Dean of the Faculty of Engineering, he is responsible for 6 EXA-accredited engineering programs with 3,500 undergraduate and 1,500 postgraduate students. Professor van der Kerk is a registered professional engineer with the Engineering Council of South Africa, honorary fellow of the South African Institution of Mechanical Engineers, and a fellow of the South African Academy of Engineers. Welcome, Prof, and over to you. Thank you.
Yeah, thank you very much, Professor Naidu. And in retrospect, I think maybe I shouldn't have been the first one because I'm going to say some interesting facts here. But maybe that is good that I'm the first person because then my other colleagues can completely refute what I'm going to put on the table this afternoon. So the title is the South Africa and the Green Hydrogen Economy. And then my question is, what are the actual opportunities for South Africa in the green hydrogen economy? And let me just see. There we go. So firstly, I think we just have to understand what is the green hydrogen economy. And of course, green hydrogen is hydrogen that is produced by making use of renewable energy resources. And that's why it's got the color green. And the main reason we're interested in green hydrogen is to decarbonize different large sectors of our society, including the transportation sector, the industry, and specifically also the supply of energy. And as we all know, South Africa has a great resource as far as renewable energy is concerned, specifically in solar and wind. And then, of course, we are very fortunate that we have quite a number of minerals which may play a significant role. Some of these significant minerals are the platinum group metals, some other metals used for the different components in the green hydrogen economy, but specifically the PGMs, which are critical for fuel cells and electrolyzers. And therefore, I'm sure we're going to hear later from the colleague from the DSTI on the investment over many years in the HySA or the Hydrogen South Africa program. However, I think there is something that we, and especially because I represented the South African Academy of Engineering, should think carefully about when we are engineers and we look at the role of hydrogen in the economy. So the first thing that's very important is that the round-trip efficiency of green electricity, if you start with 100 kilowatt hours of green electricity, you use that to generate hydrogen, you store the hydrogen, you run that back through a fuel cell, and you get, if you're lucky, 50 kilowatt hours of electricity back. So it's got an efficiency of 50%. If you look at battery electric vehicles, electric vehicles has what we call a 60 to 70% efficiency of grid to wheel. That means if I start with 100 kilowatt hours of green electricity from the grid, I put that in my vehicle in a lithium-ion battery, and then I start driving, and it goes through the electric motors, through the drive shafts. Then right there where the rubber hits the road, as they say it, about 60 to 70 kilowatt hours of energy will be available to prepare all the vehicles. However, if you look at a fuel cell vehicle, of course, now the system is much more complex. You again start with 100 kilowatt hours of green electricity. You run that through the electrolyzer. You get the green hydrogen. You have to compress that green hydrogen, so more energy is required. You load that green hydrogen onto a vehicle. You take the green hydrogen out of your storage and you put it through your fuel cell. You generate electricity, you take the electricity through the electrical motors and through the drivetrains, and eventually where the rubber hits the road, you are lucky if you get 25 to 30 kilowatt hours back from your 100 that you started with. So you're talking about efficiency of 25 to 30%, right? So I think it's very important that we realize that as an energy carrier, hydrogen is not such a great energy carrier. And of course, I'm a mechanical engineer, but I actually stand in awe of wires transmitting electricity with very, very higher efficiencies than what you see here. So specifically, if you want to look at the transport sector, there are many other alternatives available in South Africa to decarbonize our transportation sector. For instance, we already have quite an extensive rail network. And if we would rather take those 100 kilowatt hours of green electricity and send it to the wires to these railway lines with us, and just have a proper functioning passenger rail and passenger freight, and a rail freight system running, it would be much, much better as an investment, and it would be many, many rands cheaper than trying to establish these so-called hydrogen corridors. So hydrogen is really not very favorable because of the high energy losses and also the infrastructure cost. And therefore, I think there are other solutions on the transportation sector than focusing on green hydrogen as the energy carrier. As I said already, as a storage, it is very costly and inefficient. And there are many other more favorable energy storage systems or electrical energy storage systems around, specifically batteries. As we know, the prices have come down significantly. The sizes of the system has gone up dramatically as well. And then, of course, also in the South African sense, there is also pumped hydro systems, which is probably one of the best batteries for electricity that we have around. But it is always true that in certain cases, there will be some niche applications for hydrogen as a storage of energy. We also frequently hear that, that countries like South Africa and Chile are going to generate green hydrogen, put it in ships and transport it all the way to Europe and to Japan as a way to export our green energy and to green their economy with either the hydrogen or the green ammonia that will be carried around this. However, I will say that have these people looked at the map, right? So they're very close to Europe. North Africa, there's a country called Morocco. If you go to Morocco, you will find that they have a very, very well-established renewable energy sector, probably even more established than the one that we have in South Africa, but I think we're slowly overtaking Morocco these days. And it's much easier for Europe to source their green hydrogen from a country like Morocco than all the way from Chile. And these things, people will really look at the cost and the supply chain. And there is also at the moment, and I'm sure Clinton or one of the other colleagues can inform us about, what is the current demand in the market for these exports of green energy in the form of green hydrogen or green ammonia. So then what are actually the opportunities for South Africa in the green hydrogen economy? And I want to propose this afternoon that there are two where I think we can make a much more significant, a much more relevant, and also in areas where we actually have a real competitive advantage. And the one is green steel, right? So green steel is where you use hydrogen in the steel making process, and thereby the carbon footprint of the steel is a lot less. If you want to export steel, it's much easier to put steel on a freight vessel and ship it to Europe than to ship the hydrogen and the iron ore to Europe and actually manufacture the green steel in Europe. Secondly, we have already a fair amount of experience around green or around steel making, and we have we have a fair amount of very large steel plants in the country, like the old Iscor plants, the plants between Middelburg and Mpumalanga, and then of course the Saldanha steel plant down here close to Cape Town, which is ideal as a pilot to start making green steel. But furthermore, and I think this is a fact that people are not well aware of, one of the largest green steel manufacturing plants in Germany is currently being designed in Sandton in South Africa by a company called Metix. So we actually have engineers in South Africa who are already busy designing large green steel plants in Europe. So we have the expertise, we have the opportunity, and then of course we have the iron ore as well. So I would say that this is really an area where the country should put a lot of more emphasis in the production of green steel than in exporting green hydrogen or green ammonia to the European markets. The other area also where we already have some activity is in SAF, or sustainable aviation fuel. And again, this plays exactly into what we have done in the country in the past quite successfully. We can build large chemical plants. I mean, Sasol is a good example of it. We've got other large chemical plants. We know Fischer-Tropsch, right? So, and it's something that is much easier to export. It's much easier to export liquid sustainable aviation fuel than to try and export green hydrogen or green ammonia. But even more so, we are a destination, a hub for many long-haul flights. So therefore, there's already an existing market in South Africa for sustainable aviation fuel. So, Chair, what I think we should go for is we should go for these low-hanging fruits and be a little bit careful about some of these other opportunities that people are pushing forward in the green hydrogen space. Of course, to do that, we need additional public and private investment. And I think that there is a big significance here that the government, the state, should also get involved in this, especially initially, because again, it will be more expensive to put these plants up. We need the technology for scale-up and demonstration. And then, of course, and this is something, unfortunately, if you look at the renewable energy space in South Africa, where our government is not good, we need a stable policy environment, right? And of course, the global carbon pricing would be essential to that. So in conclusion, I think South Africa holds a strong potential in the green hydrogen economy. We can position ourselves strategic in this economy through some very specific industrial products, and we can do this in collaboration with smart policy, which will be critical to the success of this. And with that, Chair, that's the end of me. Thank you very much.
Thank you, Professor. Thank you very much for those wise conclusions. We'll build on that, and let me bring on Ms. Mandy Milo. And Mandy, so if you would join us on the next presentation. Ms. Mandy Milo currently holds the Acting Chief Director, Hydrogen and Energy position in the Department of Science and Technology and Innovation. She is part of the core team from the department that has led the development of the Hydrogen Society Roadmap, which was approved by Cabinet in 2021. Cabinet also approved 10 years extension of the Hydrogen South Africa HySA program from financial years 2022-2023 to 2030-31. So we've got a lot of support from Cabinet. Being part of the core team, she is now part of the interministerial team that is advising government on the way forward for the Hydrogen Society roadmap. green hydrogen commercialization strategy, and other hydrogen economy related policies and strategies. Welcome, Mandy, and over to you to do your presentation. Thank you.
Thank you so much. Thank you so much. I don't know if I'm audible and my presentation is it showing on the screen?
Yes, clear. Thank you, Mandy. Thank you.
Okay. No, thank you so much. And I just want to take this very beautiful moment to really extend our sincere gratitude from the Department of Science, Technology and Innovation for being provided this opportunity to come and just convey the role that the department, or the role that the government through the department has played in supporting in the creation of a hydrogen innovation ecosystem supported by skills development. And I think that journey has been supported by government through the Department of Science, Technology, Innovation since 2007. So these kind of opportunities, we're always appreciative of them so that we can convey what the government is doing and the position of the government when it comes to the hydrogen economy agenda. I'm trying to move my screen. Okay. So my presentation will just mainly, it's about an update on the Hydrogen Society Roadmap, which we believe it's a blueprint policy document that guides the journey that South Africa should undertake when it wants to advance in the hydrogen economy. And part of my presentation will just give you a sense of when did we start with this journey, the hydrogen economy journey, which started in 2007 through the establishment and the cabinet approval of the National Hydrogen Fuel Cell Technologies Research, Development and Innovation Strategy. And part of implementing that strategy, we implemented it through the establishment of 3 centers of competence. And also we'll talk into the portfolio that we have, the vast intellectual property rights portfolio that we have supported or invested through the support that government has injected in the Hydrogen South Africa program. And then also just touch and highlight the critical or key deployments that we have supported that are meant to really solicit buy-in from relevant key strategic partnerships that we're always seeking to collaborate with. And then after that, I will just delve into the update where we are when it comes to the implementation of the Hydrogen Society Roadmap, and then also just looking at our perspective on how we contribute to the creation of export markets for both green hydrogen and green ammonia. What have we done as government in terms of creating those platforms and participating in those platforms? And part of participating in those platforms in terms of aligning what we do as government and in terms of the decision-making processes, we are supporting or we participate in the establishment of national corporations that we have supported. And I'm looking into that, just giving you a snippet of what we've done in terms of the establishment of those national corporations and the regional corporations, as well as the international corporations that we have established and that to continue to participate as government. And then also just highlight the opportunities that are there, that we believe are there for regional integration when it comes to green hydrogen and green ammonia. And then just close on the key messages that we want to communicate as a way forward on the government perspective when it comes to contributing to the hydrogen economy agenda. In terms of the journey towards the hydrogen economy, as I indicated, it started way back in 2007 when Cabinet at that point in time approved what we call the National Hydrogen Fuel Cell Technologies Research, Development and Innovation Strategy. It was then in 2008, it was rebranded and it was then renamed Hydrogen South Africa, which we then acronym of use HySA. HySA program, which was then a 15-year program that government supported. And through the establishment of that 15-year HySA program, then we established what we call the 3 centers of competence, which we have the hydrogen in the HySA infrastructure, which is co-hosted by Northwest University and the Council for Scientific and Industrial Research. And then we have HySA Catalysis, which is co-hosted by Mintech and the University of Cape Town. And then we have HySA Systems, which is hosted by the University of the Western Cape. And part of the design And the design of the ASSAf program itself is designing a hub and spokes model, whereby we're saying that even though these host institutions are at the critical core implementation of the ASSAf program, but by design of the program itself, it allows for the participation of other key stakeholders, mainly business and industry-related key stakeholders, to come on board to participate in the development of these hydrogen fuel cell technologies that can then be integrated in identified markets. And that is why then you will find that even the key deployments that I'm going to be talking about later, those key deployments are in partnership with mainly industry to drive that commercialization aspect that we want to support as part of the ASSAf program. So as I indicated, this is the design in terms of the ASSAf program, but mainly this slide, it shows you the competencies that we have built, that we have supported through the injection of the funding that has come from government, mainly government funding that has mainly sustained the relevance of the ASSAf program. And over the hydrogen fuel cell value chain, these are the competencies that we have built through the ASSAf program. And you will see from the downstream to the upstream, we have really developed capabilities and competencies when it comes to proton exchange membrane electrolyzers, catalyst-coated membranes. We have built competencies when it comes to metal hydride, medium pressure hydrogen storage components. Even we have done some lot of work and the competencies when it comes to the development of liquid organic hydrogen carriers through HISA infrastructure at Northwest University. And also the capabilities that we have built and supported. They also, it's in terms of the, I would say, in terms of the intellectual property that can be integrated in the refueling stations, that can be integrated in the electric fuel cell powered module. So this is just gives you a perspective of where we are playing when it comes to the hydrogen value chain as part of the support that has been coming from government when it comes to the establishment or the implementation of the ASSAf program. So this is just a build-up again in terms of now when we talk about the intellectual property rights that we have built through these competencies and the competitive advantage that we've built through the support of the ASSAf program. So you would see that in terms of the IP that has been granted, we've built, we've got competence when it comes to IP granted and also the patents that have been filed through the different through the different thematic areas whereby, as I've indicated, we've got IP that really resides mainly focusing on the hydrogen metal hydrides. We've got IP when it comes to the fuel cell stack clamping systems. We've got IP when it comes to fuel cell components. We've got IP in liquid hydrogen organic carriers, in catalyst-coated membranes, in membrane electrode assemblies, and in a PGM-based catalyst. And what is the beauty about this IP that we have built, the IP portfolio? We have, these patents we have filed in over 14 countries, obviously, which is including South Africa as well. But the beauty that you always want to highlight when we conveying the message that South Africa has a competitive advantage when it comes to the product to participate competitively in the production of green hydrogen and green ammonia. Is that confidence is informed by the very fact that this IP that is reflected in this slide, it has at least 70% of that IP is linked to commercial products. So as I indicated, that in terms of the IP that we've built through the ASSAf program, we have tried to a very great degree to showcase it and demonstrate it through the different deployments that we have supported throughout the tenure of the ASSAf program, starting from 2007 to date. And what in the slide is just giving you key. It's not a comprehensive list, but due to the limitation of the slide, we can only obviously reflect what we believe is key. And one of the key deployments that I want to bring to your attention is that even during the COVID-19 pandemic, where we contributed through the ASSAf program, we deployed at least 7 fuel cell systems that contain locally developed IP through the ASSAf catalysis based at UCT through their spin-off company, HiPlat. And those 7 fuel cell systems were deployed at one military hospital to support the powering to serve as the powering for the health facilities that were catering for the COVID-19 patients. So that's the that's one of the key milestones that we've reached when it comes to the HISA program. Also, we've since 2015, we have demonstrated the capability of the IP when it comes to the conversion of electric powered forklifts into fuel cell powered forklifts in partnership with Impala Platinum Refineries. That forklift, that is fuel cell powered forklift, has got IP in terms of the metal hydride storage container that is included in that fuel cell forklift, as well as the power module that has been developed through the University of the Western Cape through HISA systems. So that forklift has been we have demonstrated the capability and is still operational in Impala Platinum Refineries in Springs since 2015. Also, I would also want to bring to the attention of the audience in terms of the work that we've done with the South African Post Office in Cape Town, where we converted three electric powered scooters into fuel cell powered scooters by integrating a fuel cell range extender that then increased the range capability from 70 kilometers to 270 kilometers. And you would understand that one of the challenges that the post office was facing was that with the electric powered scooters having a 70 kilometer range, they would travel and go and deliver the post, but then you find that then they run out of power, and then now you have to find a transportation that will transport the scooter as well as the driver. But now with the extended range to 270, at least it increases the man hours that the scooters are subjected to. So those are the advantages that we've seen so far when it comes to the deployment of these key of the key technologies in the various deployments that we have supported throughout the country. So going forward, we still with government, what we are doing as the Department of Science, Technology and Innovation, we're still trying to utilize the platforms and the networks that we have built throughout the years to ensure that we're trying to explore whether there's strategic partnerships that can come on board, and then to support the rollout, the massive rollout of these key deployments, because at the end of the day, we're trying to gain partnerships that can create a commercial pathway for these technologies to find commercial expressions in commercial markets. So that is what we're trying to do. And part of finding commercial, part of creating a commercial pathway is about scaling up in terms of a large-scale demonstration of these technologies and capabilities supported by the key partnerships that we're envisaging. So in terms of the Hydrogen Society Roadmap, so we've supported, as I indicated, we've supported the Hydrogen South Africa program, the HISA program, since 2007. So we had to take a reflection. When it came to, around 2019, when we did a second HISA 5-year review, we then said, how do we then try and ensure that we implement or we create a conducive environment that will fast track the, especially that will fast track the commercialization of these intellectual property rights that are based on publicly funded IP. So we had to reflect and then also say, what else can we do in terms of trying to ensure that this IP that has been supported by government, it also contributes to the, I would say, to the sustainable manufacturing capability of South Africa, and also contribute to the commercialization aspirations of South Africa when it comes to the hydrogen economy. So we then, one of the key recommendations was that we need to have a strategy, a broader strategy, policy strategy that government can support. And that broader strategy will then guide how South Africa transition towards now hydrogen economy, and it gives us clear indications in terms of the key action items that we need to support if we want to advance the hydrogen economy agenda of South Africa. That is when we then, as a department, we led the development of the Hydrogen Society Roadmap, which was then approved by Cabinet in September, of the 14th September 2021. And this is a blueprint policy document that guides the country on how do we create an inclusive, sustainable, and competitive hydrogen economy by the year 2050, with the goal of achieving a very just and inclusive net carbon zero economic growth for the societal well-being. So that's the vision of the Hydrogen Society Roadmap. But at the core of the Hydrogen Society Roadmap, it's really ensuring that where we have competitive advantages as a country when it comes to the mineral endowments that we have, especially on the platinum group metals, it's about really ensuring that we also create and maximize that mineral beneficiation opportunity that comes when we transition or when we utilize the hydrogen economy agenda opportunity, as well as also making sure that we create that sustainable local manufacturing capability, as well as making sure that we create the necessary commercialization opportunities for these publicly funded IP that are based on advancing the mineral opportunities that South Africa has. So the Hydrogen Society Roadmap, as I indicated, it's a blueprint policy document. It's got 6 high-level outcomes that are contributing to the achievement of the vision of the Hydrogen Society Roadmap. And these high-level key outcomes are reflected on this screen. And the beauty about the Hydrogen Society Roadmap is that it's very clear and comprehensive when it comes to really indicating what needs to be done by the country. And those clear indications are reflected as part of the 70 key actions that are clearly outlined as part of the policy document to say that for us to advance and contribute and achieve the vision of the hydrogen economy agenda of South Africa, we need to ensure that at the very least, we support these key actions. And you would see that in terms of these, the segmentation of these key actions, you would find that, let me make an example. On the key high-level outcome that talks to the creation of a manufacturing sector for hydrogen production and components, it says that there's 9 key actions that needs to be undertaken. And these 9 key actions need to be led by the Department of Science, Technology and Innovation, supported by the Department of Trade, Industry and Competition, Department of Mineral Resources and Energy, but now it has changed to Department of Electricity and Energy since the advent of the 7th administration, and the Department of Small Business Development. So the same principle, it applies to the other key high-level outcomes in terms of how do we move forward. And the beauty about the Hydrogen Society Roadmap is that as much as it's led in terms of the implementation through the Department of Science, Technology, Innovation, but it's a collective effort of government where you see that each level outcome is supported by a different department outside of the Department of Science, Technology, Innovation. So that shows you the level of comprehensiveness in terms of how the collective effort in terms of creating that relevance when it comes to achieving the hydrogen economy agenda for South Africa. And at the base of the Hydrogen Society Roadmap, one of the things that you are really advocating for, when all is said and done, it's while advocating for ensuring that there is gender equality and social inclusion, which is at the core, which we believe that it should be at the core of the transition to a low carbon economy that can really assist in addressing the triple challenges of poverty, inequality, and unemployment. Well, this slide just gives you the competitive advantage that really also we always, and as we advance the implementation of the Hydrogen Society Roadmap, we always look at the fact that this is the competitive advantage that is at the core that is supporting our positioning when it comes to the implementation of the Hydrogen Society Roadmap, making sure that at every step of the implementation levels that are outlined as part of the implementing the Hydrogen Society Roadmap, we always make sure that these opportunities that we have in terms of the competitive advantage, they are always at the core and at the forefront of all the engagements and the implementation efforts that we are driving through the Hydrogen Society Roadmap. And part of the Hydrogen Society Roadmap, it has identified key catalytic projects that can support also over and above just the Hydrogen South Africa program, but all the other catalytic projects that can really support the implementation or support the achievement of the high-level vision of the Hydrogen Society Roadmap. And these catalytic projects that are reflected in this slide, these are the catalytic projects that have been identified and endorsed as strategic integrated projects, SIPs, under Infrastructure South Africa, which is under the presidency. And we believe that part of the work that we do as the Department of Science, Technology and Innovation, we're also supporting in terms of participating in any of the platforms that seeks to contribute to the achievement of these key implementation of these catalytic projects, because we believe that as we participate in those platforms, we also provide opportunities to ensure that at least the implementation and the achievement of these catalytic projects, it also is complementary to the efforts that we're trying to drive through the Hydrogen Society Roadmap. And then one of the other catalytic projects that I identified as part of the support for the Hydrogen Society Roadmap is what we call the Platinum Valley Initiative. That Platinum Valley Initiative is an initiative that is driven through the Department of Science, Technology and Innovation, supported by the Anglo-American, ENGIE, as well as an SMME women-led company, which is Bambili. And we've been supporting this since 2021, where we did we supported the establishment of a feasibility study, which identified other nine projects in terms of 9 across the mobility, buildings, and power sectors, where we can support the advancement or the envisaged establishment of a hydrogen valley corridor, starting from Gauteng N3 corridor through Mogalakwena mine through the Richards Bay port. We're saying that those catalytic projects, like trying to support the implementation of hydrogen cluster related type of projects that can support the integration of locally developed IP across those hydrogen cluster projects that would have supported. And part of the Platinum Valley Initiative, we're also connecting it with supporting one of the flagship programs that is supported through the department, which is the Carbon Capture and Utilization Program, where we believe that through the integrating locally developed capabilities when it comes to green hydrogen and green ammonia, we can link the two initiatives to ensure that we support the hydrogen economy agenda that can really contribute to the high-level key outcomes that government has set for itself. And then in terms of this slide, it just gives you, in terms of our efforts now when it comes to establishing strategic key relationships with critical OEMs, original equipment manufacturers. Such an example, a clear example that we have, it's our partnership that we have through the HISA Infrastructure Northwest University with Toyota South Africa, in terms of trying to contribute to one of the key high-level outcomes of the Hydrogen Society Roadmap, which is the decarbonization of the transport sector. And this partnership is about the development of a mobile refueling station that can then be able to refuel the Toyota Marais that are supported through Toyota South Africa. And this already we have already deployed, or we have already completed the deployment when it comes to this mobile refueling station, which in the next coming few weeks, it will be launched and handed over by our minister to Toyota South Africa. And we will definitely send out invitations when that happens to everyone that is interested to come and witness and participate and support us in that initiative. And then part of the other work that we're doing is through Mintech. It's really creating that manufacturing capability when it comes to membrane electrode assemblies and catalysts that can then be integrated in fuel cell systems. And through the leadership of Mintech, we have there is a plan in place that is being driven through Mintech in terms of ensuring that the facility that is based at Mintech will have the commercial capability to be able to assist the country when it comes to really ensuring that we commercialize the IP that we have when it comes to catalyst and membrane electrode assemblies that can then be integrated in fuel cell systems. So this is just the roadmap and the plan in place that is currently being driven through Mintech in terms of the vision of how then by 2030 we would have established and we would have built a strong, sustainable, I would say, local manufacturing capability of these components that can really position South Africa in a very favorable manner when it comes to competitive advantage when it comes to participating in green hydrogen and green ammonia. Well, this slide just gives you what we call the Interministerial Committee on Hydrogen Economy. I think at the very core, I saw the presentation from Prof. From Stellenbosch University, where he said one of the things that is important, that key enablers, is to really create a conducive environment, policy environment that will allow, that will attract favorable investments from investors. And one of those favorable policy enablers that we're trying to implement is the Ministerial Committee on Hydrogen Economy. We believe that this is an IMC or a committee structure that will assist with the alignment, coordination of key efforts that are being driven from the different departments. Because one of the things that challenges that have been mentioned as part of us engaging with key stakeholders is that currently the system, which I'm aware of and acknowledging from the government perspective, is that we are currently very much segmented. You find that there is an interested stakeholder or interested investor that wants to come and support a large-scale implementation of a hydrogen-related project. But you find that because of the barriers, the policy and the regulation, the regulatory and licensing barriers, they tend to be causing a fatigue, and they tend to really discourage potential investors. So we're trying to say that through we want to collectively as government to be led by the ministers of various departments, for example, key departments that are really needed to play a key role in the hydrogen economy, to try and see how then do we make sure that we seamlessly align and coordinate our efforts as government, so that when investors come on board, they don't become fatigued with the processes that are currently in place, but we rather build processes that will be very much effective in terms of encouraging investor confidence and investor investments into the large-scale hydrogen-related initiatives that can support the implementation of the Hydrogen Society Roadmap. So this is just give you a structure of how the Interministerial Committee, it was approved by Cabinet in last year in February 2024 under the 6th administration. So currently now we are at an advanced stage where we are just are waiting for a communication from the Deputy President to convene the structure. And this structure will be obviously led at the Deputy President level, chaired by the Deputy President. And we believe that this is the structure that really will harmonize government's efforts and will just contribute to the investor confidence that is needed for the key stakeholders to come on board and support the hydrogen economy agenda of South Africa. And this structure, in the interministerial structure, obviously it will also be supported by the various work streams. Those various work streams, then they also enable the interaction with the relevant key stakeholders, be it in public, in private, in business, and industry-related key stakeholders that can inform the decisions that can be made at an interministerial committee that will support the advancement of the hydrogen economy agenda of South Africa. Well, this slide, it shows you it shows you our efforts when it comes to really trying to maximize our participation and the connections that we have as part of building that creation of an export market, especially for the hydrogen and ammonia. And one of those platforms that we have that we're supporting through the department is our membership at the membership of the Clean Fuel Ammonia Association, which is a very critical platform whereby it's led by the Japanese government and all the critical stakeholder companies, big companies that are expected to play a key role when it comes to the production of green hydrogen and production of ammonia and export of those commodities. Those are the companies that are playing that are very much active in this structure. And we assume that membership in November 2023, led by our minister. And this is a structure that we believe that we are utilizing to really again to align our efforts to ensure, because as government, we always want to make sure that whatever that decisions we make, they are decisions that are relevant globally, regionally, and domestically. So as participating in these kind of platforms, we align our efforts and ensure that our efforts really, when it comes to pursuing green hydrogen and green ammonia related agendas, they are aligned to globally approved or globally accepted standards. So those are the platforms that are assisting us in ensuring that we benchmark our efforts accordingly. And then this, and also regionally, because we're not only focused on really our attention just on the international side of things, but also even regionally within African African context, within the African context. And part of that is us participating and making sure that we continue maintaining the relationships that we have with our key partnerships within the regional context, be it in Namibia, be it regional context, even domestically, within our own spheres, which is really making sure that we build those relationships with the relevant provincial governments that can support the hydrogen economy agenda. I think I've mentioned, yes, in terms of the regional cooperation, we participated in the first, I would say, inaugural green hydrogen summit that was supported by the Namibian government, and our deputy minister was there to really also communicate in that platform our efforts in terms of what we do as South Africa in trying to contribute to the creation of a hydrogen innovation ecosystem supported by skills development. And we continue to support those kind of engagements at those regional levels, because we believe that as much as we also have to be focused on our own efforts within South Africa, but we also need to also explore and really opportunities that we can derive in partnering with our SADC partners, as well as our regional partners that share the same interest and common vision when it comes to the advancement of the hydrogen economy agenda. Okay, and then this slide is just this slide shows the opportunities for regional integration. Basically, just shows you where we believe that we can, through the engagements that we have, the opportunities for partnerships in these key enabling aspects of that will support the hydrogen economy agenda. We believe that we are looking for partnerships that can really support skills development and public awareness when it comes to hydrogen economy agenda. We are looking at always opportunities that can be created whereby we can be able to deploy cross-border infrastructure such as your pipelines, transmission line that can link production with demand centers. So these are just the key enablers or key principles that are assisting us in terms of how do we engage the opportunities that are there for us to forge strategic partnerships that can support the vision and the advancement of the hydrogen economy agenda of South Africa. So this is my last slide in terms of the key messages. Yes, this just for us, I think South Africa, I think when all is said, with all these key points that you've mentioned on the slide, when all is said, South Africa is ready for business, and we're always looking for opportunities whereby we can really advance our interest and ensure that really opportunities of partnership with like-minded and stakeholders that can contribute to those vision that we have when it comes to pursuing the hydrogen economy agenda of South Africa. So I will end here, colleagues, and thank you once again. Thank you so much for the opportunity that has been provided. It's very much appreciated, and I'm open for any questions of clarity that I may address at a later stage as part of this conversation. Thank you.
Thank you, Mandy. Thank you very much. Thank you. Let us continue, colleagues, and we'll take the presentation from Mr. Naidu from the Department of Science and Innovation, and he's with Technology Innovation Agency. If Mr. Naidu would get ready to present. Raj, you're going to help Ms. Naidu with the slides? Oh, perfect. Perfect. Right. Mr. Naidu is member of the executive committee at TIA, and he holds a Bachelor of Technology degree in operations from UNISA, as well as an MBA. And he's chair of the University of Johannesburg Industry Advisory Board. And Mr. Naidu maintains a strong focus on climate change, the low carbon economy, the just energy transition, e-mobility, and strategic materials. He also serves as a committee member of UNESCO. Over to you, Mr. Naidu, for your presentation. Thank you.
Thank you very much, Professor Naidu. Can we go to the next slide? I'd actually like to handle it myself, but so basically, if you look at where we stand in terms of hydrogen, we in many ways tied in the hip to with the DSTI, which is our principle. So in terms of how we plan to move forward, and we actually support technologies. Just a quick background. We actually support technologies from a proof of concept. We usually take them to prototype, then to demonstration of subsets, and we commercialize technologies. So our specialty is the commercialization of technologies. And in this whole endeavor, we actually are working with the DSTI to see how are we going to fund the technologies that were produced by the HISA program. Also, we do our own support in terms of technologies, which I'll give you examples of in terms of hydrogen. But in terms of commercialization, we spend a fortune in terms of the HISA catalysis, HISA systems, and HISA basically infrastructure. So we decided, let's look at this IP and let's see what IP we can go out there and actually implement. And in terms of commercialization, we need to get the product out there, to get partnerships, to see how we're going to get these technologies to commercialize. I think very important for us, our mandate is to create local economies. In TR, we supported many technologies from mining to health, to ICT, in water, in different parts of energy. And there were many successful endeavors we got. And some of the companies that we've got actually expanded abroad to basically many countries. So in terms of creating local economies, I think it's important to look at how do we create these economies. But in terms of creating these economies, we really need to look at partnerships, number one. We really need to see what the market will take. And importantly, to see, I know people may have it in their mind to say that we will definitely sell this product, but we need to do a complete market analysis to see would it be taken up in the market locally and abroad. In creating local economies, we look at jobs, we look at profits to get this market out there. So we try and attack, we're trying to attract and facilitate these late stage technologies, trying to get them into market. And in some of the examples we have, when we supported forklifts in terms of power modules and to reduce this hydrogen in terms of pressure for storage and working on MEAs, we spoke to various players in the market from Toyota and Exa, and a lot of them are interested in this forklift. So it is something that we want to gain traction on to actually move this whole commercialization strategy forward. Can we go to the next slide, please? So what is very important is partnerships and collaboration. So we, as we said, we try and support the various stakeholders to create a supportive ecosystem for innovation. I think what is crucial is there's an opportunity, especially with the IP, with the HISA program and various technologies, to get actually SMMEs aboard. To say there's an opportunity, let's try and see how we can actually support these SMMEs. And one good example is when TR initially supported HiPlat, and that was eventually taken by Bambili. I mean, there was an opportunity there for this whole MEA program to actually gain traction in terms of the whole Bambili program. And I think that was one of the examples. But the smaller players, which is the SMEs, need to get on board. And we need to support them to see how we can actually get this whole technologies into place. There's opportunities with MEAs, there's opportunities with forklifts, there's opportunities with heavy trucking. We want to speak to the mines to get the mines on board. And this whole issue about value chain and beneficiation on the PGMs, I think that's quite important of this whole program. So the government has been working and funding these technologies, and you'll be amazed that there's a lot of good work that was done. And I think the government had that the foresight to see that these technologies would be a part of this whole new economy that's coming in the future. So I think that was good foresight, and a lot of money has been put there, and a lot of IP has been generated. So in SMME support and skills development, I think that's extremely important. We need to support local economies. We need to create jobs. I think the main thing is we can have the best technologies in the world, or we can, and we do compare with some of the technologies we've got at HISA, because I'm part of the advisory board on some of those ASSAf, and we meet players from internationally, and they're quite actually in awe of the technologies that we've developed. But what is important is if we do not create local jobs and we don't create an economy which is going to benefit, I mean, but the people of this land, I think then we lost a whole plot there. That is why we need to come with the commercialization skills to create the jobs, to create the economies, and to see how we can really use the advantages we have in this country. I mean, we've got the climate, we've got the opportunities to present, we've got great companies like Sasol will produce aviation fuel. So this is an opportunity for us to really go forward. In IP management and protection, we'll also support them, especially in licensing. And obviously, in commercialization strategies, we've got to look at the business plans and what the business models are and what the business opportunities are. Obviously, will be public awareness and engagement with different industry partners. So we really want to get this ball rolling and get things really done for this commercialization or this economy to start moving. Next slide. Next slide, please. Okay, so basically in the decarbonization of heavy-duty transport, that is where our opportunity is. We looked at that also in a center of excellence for manufacturing. We're going to try and look how we're going to support that. But very important, I think, in terms of the export of green hydrogen market, where we have to convert that hydrogen into green ammonia, and there's always a market there, and I don't think the Europeans would have supported this if there was no market. So I really believe there's a market there. Next slide, please. As I said, the export market, the power generation, the industrial and transport sector, which is a huge, it actually showed huge benefits. We actually got a mine involved there, and they're very interested in that. Forklift has been actually working at that particular industry for now close to about 5 years, and there's huge opportunities there also for local manufacturing. I just want to get to the end of this slide because I covered, I think, but there's a lot that basically Mandy covered that I repeated here, but okay, let's go to the end of the presentation, please. So the catalysis, basically, I think Mandy covered in terms of infrastructure. The next one. All right, there's also the systems that's covering. We're currently supporting them with the whole systems with the forklift, as I indicated, and the hydrogen fuel vehicles. Next one. So in terms of the hydrogen project supported by TIA, first was a hybrid. The other one was the fork with the truck fuel cell project. We've got a truck fuel cell project at the moment where they actually fill in this hydrogen and the trucks. It's for the larger trucks. The forklifts, we supported them in terms of a power, in terms of constructing a whole new power module and reducing this whole basically pressure of this hydrogen for it becomes storage. And currently we're working with another project with the NMU on hydrogen infrastructure. So in terms of how we see this whole hydrogen technology, we want to support the hydrogen technologies, but we're putting funds into them. We realize there's a whole potential in terms of the local economy, and we're trying to see what competitive advantage we're going to have in terms of the African continent and going into the European market. So there's a huge opportunity. And I was quite impressed with what Professor Vickers mentioned also on the green steel part. So we're trying to look at all avenues to see which is the better and which is going to give us the most value in terms of our competitive advantage, and to see which value chain will create for us the greatest benefit for the local economy that we want to create. Professor Naidu, I think that ends my contribution. Thank you very much.
Thank you, Mr. Naidu. Thank you very much. Let's take the last presentation, and we'll bring on Dr. Clinton Carter-Brown, the head of technical at Innertag, South Africa. Dr. Brown, if you may get ready. Dr. Brown provides specialist technical support and project program and organizational management services in the area of energy systems, energy modeling, utility asset management, power system simulation, electrical grid planning and design, power generation procurement, and grid integration. So Clinton has held senior leadership roles in the energy domain in the public and private sectors. He spent 18 years at Eskom. Thereafter, he joined Oricon, and thereafter he worked at the IPP office and CSIR in the energy research sector. Clinton is now with Enertag, South Africa, as head of technical. Let me hand over to Clinton. Thank you, Clinton. Welcome.
Thanks, and good afternoon, Prof. Naidu and all the listeners. Yeah, thanks for the opportunity to present. So I'll be giving a project developer's perspective as Enertag, being a globally based project developer headquartered in Germany, but working substantially in Africa and in particularly Southern Africa. So just to give you a bit of an overview of what we'll be covering, a little bit around Enertag. We'll unpack a little bit about some of the projects that we've been doing in South Africa. I'd like to dive a little bit into one of our key projects in Southern Africa and Namibia, just on the other side of our borders, being the Hyphen project. Give a bit of perspective of what, for example, the South African market is competing against. Prof. Vickers mentioned, for example, the opportunities closer to Europe and the shipping costs. South Africa is competing globally in terms of being a possible provider of various P2X in products, and we need to be globally competitive. So give a bit of perspective there and some key observations. So just a little bit about Enertag. We've been developing P2X projects for the last 15 years, primarily headquartered in Germany. We're over 1,000 staff. I think of key point to note for the purposes of this presentation today is that we have over 16 gigawatts of projects in various phases of development in the P2X space, albeit a lot of that is in earlier stage development. We are developing a range of projects globally. So Enertag started in 1992, primarily as a wind developer. So most of our capability is built on that, which is really the cornerstone of P2X. You need to be able to produce low-cost electricity, and you need to be able to do that well. And that's a core competence that we have and that we have in-house. I think really important to note is that we were one of the first pioneers in terms of going into the green hydrogen and P2X space, with the operation of the world's first commercial plant or facility near our headquarters in Germany. And we have subsequently, and especially in the last 5 years, been aggressively developing projects on a global level.
My apologies.
Yes.
My apologies, Clinton. Your slides are not coming through. Your slides are not coming through. Raj, can you help?
Sorry. And now?
1 minute. Yeah, try share.
Now we can see him.
Yes, now we can see it. Thank you, Clinton.
Okay. No, thank you. Thanks for that, Prof. Naidu. Apologies for that. So maybe just briefly then, in terms of the previous slide, Enertag at a glance, because these slides will be available. So audiences, please welcome to go through in their time. 16 gigawatts of projects. We've been in this space for quite a considerable period of time. And most recently, whilst we still focus on our core competence, which is primarily wind energy, battery systems, PV systems, and then now a global play into the P2X space. So this is really the map showing our projects globally in terms of where we are developing projects. As you can see, it's quite considerable. So we have a global view of the P2X, the opportunities and what we're developing, and hence where the particular market opportunities might be for South Africa as well as other markets and regions. We have 2 offices in South Africa, Cape Town and Johannesburg. One of our key enablers or capabilities is having built and owned and operated our own combined power plant in Uckermark in Germany, something that we started to develop more than 30 years ago. We now have more than 600 megawatts of wind, 21 megawatts biogas. We've got batteries as well as more than 20 megawatts of PV. And we operate the complete sub-transmission distribution grid, connecting directly at 380 kV into the transmission system, operated in this case by 50 hertz. So we have a deep history of developing large, complicated plants and facilities, which is a prerequisite for playing in the global P2X space, and the complexity, the technical and commercial complexity that goes with such projects. As mentioned, we were globally a leader in terms of doing the first commercial electrolyzer project. It's very small; it's under 1 megawatt. Incidentally, when we went to market in those days in 2011, we were unable to secure an acceptable electrolyzer. So we, as Enertrag, designed, built, operated, and commissioned, and now operate our own in-house design, built, and delivered electrolyzer. So we have that level of innovation and technology innovation and development. So it's a facility we're particularly proud of. It's obviously very small scale relative to what's being developed globally, but nonetheless has been a key enabler for us. In terms of the projects in South Africa, I'm just going to touch on two. There is another opportunity, but I won't be publicly going into any specifics of that at this point in time. Vic has quite rightly mentioned two immediate areas of specific interest in the South African space, and that being green steel and sustainable aviation fuels. So on the sustainable aviation fuels, we've been co-developing a project with the project partners there being Sasol and Linde for the decarbonization of a portion of Sasol's Secunda facility, as would involve an installation of a fairly substantial wind and PV facility, directly grid interconnecting that into Sasol Secunda to a roughly 200 megawatt electrolyzer that would then feed green hydrogen into the existing Fischer-Tropsch reactors at site at Secunda to produce roughly 42,000 tons of green aviation fuel annually. Of course, the real beauty of a project like this is that the market here is being driven by EU regulations, which is essentially forcing EU-based airlines to have a certain amount of sustainable aviation fuel in their mix, failing which they have to pay fines. So there's a very strong economic incentive there for this decarbonization. Of course, a fuel produced through P2X and green hydrogen is substantially more than the traditional grey product, and there needs to be a market that's prepared to pay that. In this case, there is, given the particular incentives and fine regimes that the EU is imposing on the airlines. So this essentially would be to wrap our local sun and wind into green hydrogen that gets exported as a sustainable fuel that then gets used in the EU. So a very exciting opportunity. Unfortunately, the project is presently stopped and will be revived as and when the market conditions support. So there are some very specific enablers that we need for this project to proceed. In particular, a regulation linked to the certification of the fuel and what we call flexible allocation. I won't go into the specifics of it, other than to say that in order to be able to utilize existing brownfield facilities like Secunda and to be able to decarbonize them, there needs to be certain allowances for that in how the products are certified. And of course, that is a key point of lobbying of the South African government, the EU, the German government, to be able to unblock those regulations that then would allow the cost-effective export of green sustainable aviation fuel. In this case, from Secunda through Sasol, but it could be applied to other opportunities as well. So this is a very exciting, very interesting particular project that we as Enertrag have been very involved in. We're also developing a large green ammonia, green energy cluster in Tabosh in the Northern Cape. I think the point at this point is that we have a very large development portfolio of wind and PV that we're developing in South Africa. We have projects, for example, in the Northern Cape that are quite well located to existing producers of carbon, such as cement factories and others. We also have the grid constraints that I think really fairly well known in South Africa, and the inability to necessarily fully grid connect all of the renewable PV and wind in those areas. So there is a particular opportunity to look at P2X, where instead of trying to export those electrons to, say, the load center in Gauteng, one would then co-locate the electrolyzers, create the load in the Northern Cape, and build it out. A number of key challenges for these projects: water availability in these arid areas, transport and logistics. How do you move the products in and out? And how do you ultimately ensure that it's a cost-effective solution compared to your peers? So it's still an earlier stage development project that we are working on locally. I mentioned earlier that I just wanted to touch on our project in Namibia, Hyphen, and it's not South Africa, but it is Southern Africa, just to give a sense of some of the design features and what we see to be globally competitive in the likes of green ammonia. We're talking about a tradable product that can be relatively easily shipped in the form of ammonia, whether it's green or gray, the end product is the same. But in order for us to be able to cost effectively access, whether it's a Korean or a Japanese or an EU market, one needs to have the lowest cost product and be globally competitive. So we've been developing the Hyphen project. I'll show you a little bit more in terms of the specifics of it, but it's a really world-class, world-leading project that is now at an advanced state of project development going into feed. It's extremely ambitious. We're talking about in excess of 7.5 gigawatts of renewable energy, wind and PV, across the two phases that are roughly equally sized. So the first phase of the project alone is literally an order of magnitude of the entire Namibian power system. It's a truly massive project that, of course, has an equally eye-watering price tag. The key, what is being driven here is that in order to get the ammonia costs to be as low as possible, you need scale. And a lot of that scale is driven by the size of the green ammonia loop, synthesis loop. So in order to get the levelized cost of ammonia down, which is our primary focus, it's not minimizing the cost of the electricity or the hydrogen, it's the end product being ammonia, leads us to a project of this size. And what is particularly interesting and exciting about Lüderitz in Namibia, if I go into the next slide, is literally the wind and the PV resources are globally just simply fantastic. And we're talking about onshore wind with wind speeds in excess of 10 meters per second average. We're talking about capacity factors of well in excess of 50% for onshore wind. By way of example, the best projects in South Africa are typically high 30s, early 40%. Most of those now fully developed. So it's a phenomenally good wind resource paired with a very, very good, equally good solar PV resource, where there is a lot of land mass available. And it's all basically co-located at the Lüderitz port. And it is a completely standalone project, which in itself has a number of challenges given the size of what is being developed there. But essentially, we build out the solar, the wind, the battery storages, the entire sub-transmission and transmission grid that interconnects a 7.5 gigawatt power system, the roughly 3 to 4 gigawatts of electrolysis, the water pipelines, hydrogen pipelines, and transmission grids that move the hydrogen, the water, and the electrons. And then all of the infrastructure that in this case would be located at the Angra port close to Lüderitz, the ammonia synthesis, the nitrogen extraction, the port shipping logistics. We have to build, and we will build all of it with the overall objective here and the optimization of this entire energy system being to minimize the cost of the ammonia as it would leave the port and be shipped to its international destination. We have been appointed through our involvement in the Hafen consortium for the first two areas, being Springbok and Dolphin, and those are the two that sum to 7.5 gigawatts. Just to give you a sense of the future concession areas and the potential end state size of this project in Namibia, you can see the dark blue, the additional future concession areas that could be developed. And with the infrastructure that we're putting in place, phase one being also sized, and the commercial arrangements to be able to unlock those future concession areas. So excellent wind, excellent solar, and with a large long-term plan that would certainly result in some of the cheapest potential green ammonia globally. So just my final slide in terms of then the key observations. You know, if we look across our portfolio of projects and the kinds of opportunities that we're developing globally and in the region and in South Africa, these are a selection of some of the key project enablers we're seeing that really position projects well. So very important is that you need low cost, high capacity factor renewable energy, and in the form of solar, PV and wind. And South Africa is fortunate to be blessed with good PV and wind, and in some regards it's world class, but it's not necessarily as good as some other parts of the world. So we need to be mindful of that leveraging that alone is not sufficient. We need to have largely vertically integrated projects. So in South Africa, when you need to wheel, where your renewable energy is remote of your electrolyzer and you need to go by the national grid, you pay wheeling costs. And that substantially adds to the cost of projects, and it negatively impacts the business case. So projects that can build their own grid, avoid wheeling, are completely co-located, such as Hafen, already have a substantial, leg up in terms of projects as compared to, say, having to wheel, which unfortunately would be the case for many projects in South Africa, is the requirement or the necessity to wheel, which does introduce a challenge. Really important as well is avoiding third-party project risk. I mean, you can't bank a project where there's a dependency on other projects that are uncertain. So, many projects may have a dependency on a port upgrade, a railway upgrade. If those projects are not internalized and part of the execution and delivery, that really introduces a massive third-party risk, which in many cases is a project killer. As mentioned earlier, we as EnerTruck, we focus extensively on optimizing the entire value chain. So for us, it's not about achieving just the cheapest cost of electricity or the cheapest cost of hydrogen. It's about producing the cheapest cost of the end product. So if that end product is an ASSAf, or if it is a DRI green steel product or a green ammonia product, how does one optimize the entire value chain from the renewable facilities, the grid, the electrolyzers, the chemical plants, the synthesis, the battery storage, the pipelines, the hydrogen storage? It's about the overall economic optimization of the entire value chain to minimize the net cost, because that ultimately is the value proposition, is the cost of the output product. So that's something that we focus on and where we are globally a leader. Very important is the ability to pay. And I think we've seen a lot of hype in the green hydrogen market with a lot of expectation of reducing pricing, very aggressive views on cost reduction of components like renewables and electrolyzers. But ultimately, many P2X products are presently substantively more expensive than the gray equivalent. So there are not necessarily always customers that are willing to pay, and very importantly, are prepared to pay via a long-term offtake agreement that makes these very capex-intensive projects bankable. There are specific situations, I've mentioned a couple, such as ASSAf, and particularly in the green steel environment, where market conditions, the opportunity to access certain projects, various regulations, would mean a very competitive product potentially from the South African market. And there are very niche specific opportunities that we think are very attractive for South Africa. And linking to that is the ability to repurpose existing brownfield facilities. So, like, for example, in the case of the High Shift project with Sasol Secunda that I mentioned earlier, you know, a big portion of that project that makes that project very attractive is the fact that we would be leveraging an existing gas to liquids facility in the form of Sasol Secunda and all of that sunk investment. So that is a massive advantage to projects compared to complete new greenfield build. There's also this need to build on combined power plants. I touched on that earlier in terms of very often P2X might not be the starting point, it could be an end state. So as in the case of what we've done in Enertrag, initially building renewable wind and PV battery systems, anchoring those renewable energy plants with green electricity and related purchase agreements, providing services to the power system, to the transmission system operator, and then in time adding the likes of electrolyzers, P2X, and green hydrogen. Subsidies and grants are very appreciated, and they do help de-risk projects during project development, but unfortunately rather limited when it comes to large-scale project capital costs, and that's where the vast majority of the challenges are. The ability to finance and make the project financing work, and the ability to expect large subsidies for capital costs is a serious challenge and a disconnect generally in the P2X projects globally. And then, of course, finally, access to low-cost capital. That's what you need in order to have certainty of investment returns and access low-cost capital. These are very capital-intensive projects, so accessing quality low-cost capital really assists the business case for the portfolios that we're looking at. But I'll pause there. Thank you, Prof.
No, thank you, Clinton. First class. No, thank you. Thank you, colleagues. And let me come on here. There we are. There we are. Now, thank you to our four presenters. Well done. I know some of the presentations went on a little bit longer than anticipated, but that's okay. We've received a lot of material, And I think, let me share and answer one of the questions. Are we going to receive the presentations? Yes, you're going to get from ASSAf and the Academy a package, and the team will guide us going forward. But you will certainly receive a full package from the organizing joint institutes, Academy of Science and Academy of Engineers. Colleagues, going forward, now I just want to set the groundwork for the Q&A session to follow. I want us to also recall that carbon-based fossil fuels, coal, oil, and gas, have powered successive industrial revolutions, starting with the steam locomotives, transportation in the Industrial Revolution of 1, then moved on to electricity generation, bulk electricity generation, revolution number 2, and now we well into the 4th Industrial Revolution. And again, they continue to sustain the economies of the global community. But in the words of the United Nations Secretary General, he's very clear. It's got to stay in the ground. Coal, oil, and gas has got to stay in the ground. We have to let go of that energy resources, and that's all being done in terms of the impact on the climate. The climate impact, global warming, it is very serious. And again, we are racing to overheat and to virtually destroy. It becomes an existential issue now, and we've got to change. And that change cannot happen instantaneously. It's going to be complex. And again, Prof. Van Kerk mentioned the most efficient carrier of energy is electricity, and we agree with that. And again, now we've got to see now, how can we bring on hydrogen also as a contributor, as an energy carrier, but within its context, within its boundary conditions for application. And I think that was set out very, very nicely from Professor Van Kerk's presentation and followed through with the rest of the presentations that were tabled from our colleagues. You listened into Clinton Carter Brown that wrapped up stating, these are the constraints and the challenges that we are working with. So in that context, let's start working through some of the questions that we've got on hand, and we've got ourselves at least half an hour to digest them. Raj, if you want to help me, and we'll go through with the first set of questions. Let me lead on the first one for Professor Van Kerk on green methanol, sir. If you could talk a little bit about that. Thank you.
Yeah, thanks, Pat. I already answered that also in the Q&A, but of course, green methanol is a biofuel that is derived from the fermentation of sugarcane. So it's not directly related necessarily to green hydrogen as such. And in the South African context, unfortunately, we never got our biofuels strategy sorted out. And I would also venture, that as we are going to have fewer ICE or internal combustion engines, the market for liquid fuels are going to be kind of questionable. So I don't see that we will go that way. But at the same time, I think that, we all know that people are using the sugar. We're actually not too bad at growing sugar cane in South Africa. So it could be something that can be used to augment the fossil fuels with some biofuel mixtures, as they've been doing in Brazil now for many decades.
Thank you, Prof. Thank you. Very good clarity there. Thank you. It's an innovation, both policy and TIA. And the HISA program that was launched and is still continuing and is going to go up to 2035. Any area that you would think you could support in terms of skills development, workforce capacitation? There's a lot of questions around that on the chat. Any comments on skills development to support your program going forward? Mandy or Daya?
Mandy, do you want to go? Do I need to just say
anyone?
Just say something, please.
Okay, so, I think. Okay, you can go ahead, Daya. I will add if there's a need to add.
Okay. So basically, in terms of the whole skills development, you could see that the whole HISA program built a lot of intelligence and skills in the various sectors, from infrastructure to systems and catalysis. But interesting enough, I see the CETA has actually came about with a whole hydrogen program, and that was accredited by QC2O. So I think the CETAs are getting on board with the FETs and with the various universities, that they want to actually start producing courses and material, and more importantly, to have our force ready, that when the transition occurs, also with the just energy transition, that if you're not going to look at fossil fuels any much longer, there would be a natural transition to actually get people trained with green hydrogen and hydrogen production. Mandy, maybe you can take over. Thank you.
Yeah, come in, Mandy.
Okay. No, thanks a lot. I fully support the sentiments shared by Daya. Just to add on that, the skills component side of things. Oh, can you hear me? Hello?
Yes,
we can hear you.
Yes, we can hear you, Mandy.
Okay. No, I was just saying, just to add quickly, is that the skills component, I think when I started was that as government, we always maintain that we're trying to create conducive and to contribute to a creation of a conducive hydrogen innovation ecosystem supported by skills development. So skills development has always been at the forefront. When we're supporting the technology development, it's also supported by the skills development, in the sense that from the early stage, when we're supporting the HISA program, we're supporting the master's, PhD, and PhDs, as well as there is a cohort of postdocs that have been supporting in the technological development areas that we've outlined. But the recent focus, again, in addition to what we've been supporting, it's also to look at the downstream and the upstream in terms of the low skill rated type of skills, like your artisanal skills and your technician skills through the TVET institutions. That has been now really focusing on that with the support of the Energy Water CETA. So we do have a memorandum of understanding with the Energy Water CETA where it's supporting the skills development, especially in line of the energy storage, on the energy storage flagship program that we're supporting as the department. There, it's about even operation and maintenance of systems, energy storage related systems, as well on the fuel cell side of things. We're also supporting the maintenance and operation of fuel cell systems. And those are the skills that we're also trying to develop, because we're saying that if we're going to achieve the hydrogen economy agenda, it needs to be supported by the high level skills, but also the other skills that are really required, which is important. And it's about really the artisanal and the technical skills, because over and above that, these systems have to be maintained, these systems have to be operated on. Who's going to do that if we don't have those skills? So we are looking at that. So it's a whole comprehensive approach that we're undertaking as the department. Thanks.
No, first class, first class. Thank you for that, Mandy and Daya. I think you've answered that very well for us. Thank you. And I think let's accelerate on especially the lower end. I know at the top end we've done a fantastic job with the universities, but we'll accelerate on the low end. Still with the ASSAe program, the issue around the platinum group materials is now becoming a conversation, not just nationally but globally. And we've listened in last week to the peace that was settled between the Democratic Republic of Congo and Rwanda, and the strong focus on getting into the rare earth metals components. And I think this is a new opportunity for us. How are we going to position South Africa in this changing environment of rare earth metals? Not just PGMs, but look at all the materials that we can bring forward and beneficiate and then put onto the international market. Any thoughts from my colleagues on TIA, then to the Professor and Dr. Clinton?
So, Professor Naidu, I think in terms of the platinum or the PGMs that we've got in the country, I think that's a huge benefit, because South Africa holds basically close to 70% of the world's platinum. So that's going to be a huge benefit to us. In terms of the rare earths, but we do have a couple of rare earths in this country, and I think there's an opportunity there. But but there's also rare earths in Africa which could be used. So I think that the issue comes in: are we going to supply it as a raw material, or are we going to beneficiate? So there's an opportunity for us actually really to use this beneficiation to actually increase the value of our exports.
Yes. Yeah, I think we've got to look beyond just ourselves and PGMs. Look at Africa now, continental Africa.
Yes,
and again, the whole rare earth metal portfolio and how we can take advantage. Prof. Van Niekerk, over to you. Your thoughts on that?
Yeah, no, but I think, it is something that we as a country has not actually been very good at, and that is the beneficiation of our minerals. We basically dig it out of the earth and then put it on a ship, or first a train in a ship, and then we ship it out. So therefore, I do think that we should work towards the beneficiation. But I also want to point out that you must remember that South Africa, platinum mines, they're in the global supply chain, right? So we will pay as much for the platinum that we mine than anybody else will pay for platinum. So that is something that we just have to keep in mind.
Yeah. Right. No, certainly.
Maybe if I can
prices will dictate. Please do. Come in, Mandy.
No, maybe if I can just add quickly. I think from the government perspective, I think you may be aware that we have the Department of Mineral and Petroleum Resources has recently shared, I think a few weeks back, shared what they call the critical mineral strategy for South Africa. It's a draft. And this is a draft, and it's now what they're looking at. The next step, it's about really building on what an implementation plan that can give rise to the vision of that critical mineral strategy. And it's about really how to position South Africa in terms of making sure that we leverage opportunities that are there when it comes to the minerals endowment that we have, whether including PGMs, the lithium, iron, the manganese that we have, the cobalts and the iron and so forth and so forth. So what as the department in terms of contributing to the implementation to the draft implementation plan of the critical mineral strategy. We're also looking at now in terms of the potential beneficiation opportunities that are there, and including the technologies and at what level in terms of the TRLs, the facilities that are required, the economy of scales that will be required, and what will be the low-hanging fruits that will that we can consider when it comes to creating the value opportunities that are there when it comes to the potential beneficiation opportunities. And we're also looking at the fact that we're also doing a study, an assessment of the current projects that are there that we are currently embarking on, and also the opportunities when it comes to the EVs versus the storage applications versus the lithium-ion batteries and the vanadium opportunities. So this is the work that is currently being undertaken. But overall, the question you're asking, Naidu, is that it's embedded in that strategy, which will really position South Africa to make sure that we maximize the opportunities that are there, that when it comes to critical mineral endowments, including the PGM aspect. Thanks.
Excellent. No, excellent. Thank you, ma'am. Thank you. And I think it came across very clearly today that we've grown intellectual capital in academia. I think if we bring together that collection of intellectual capital for the national interest, I think we can get great success. Dr. Clinton Carter-Brown shared with us the constraints that they have experienced at the industrial level. But I think with the intellectual capital that they've grown, we can carry that forward onto the global agenda now of how do we address this sort of beneficiation of rare earth metals, which is being driven by the electric vehicle industry. And then again, we need to catch that wave as it gathers momentum. Any thoughts on that, Clinton Carter-Brown, from your end?
I think Prof. Vickers raised the very important point, around the actual pricing of, for example, the minerals or the materials in South Africa. Platinum, for example, is globally priced, and these are private sector mining entities that are there for profit, and rightly so. They create a lot of employment and opportunity for South Africa. But the fact that we mine it, and in the context of, say, for example, electrolyzers, the amount of platinum that's required is relatively small, and of course, a lot of ongoing R&D to minimize or completely remove the likes of platinum and the requirement for platinum. Given the likes of South Africa sit with 70% of the reserves, there is ironically a massive global R&D push to minimize the need for minerals such as platinum, given the dependency and the lock-in of certain geographies, including of South Africa. And the fact that we've got the material doesn't necessarily mean it's cost effective to manufacture the electrolyzer in South Africa, especially if there isn't a market for the deployment of that. And we see the same in the renewable space, whether it's PV or wind. We need an enabling policy environment, and I think links to the recent publication and release of the South African Renewable Energy Master Plan, to be able to localize industries, but it requires policy certainty, and it requires markets and market stability and an enabling broader macroeconomic environment. Having the platinum alone is only one small piece of the puzzle, and we still need to come up with the right enabling environment, in my view, that would create local manufacturing. We also need to be careful that in our eagerness to locally manufacture, that we might impose duties or tariffs that actually make these technologies more expensive in South Africa and actually hinder local deployment. As we've seen with the likes of PV, large-scale massive production, very cost-effective, very attractive now to implement on scale in South Africa. And we get a lot of economic value from PV deployment, even if the panels are fully imported. So we need to find that right balance between allowing these new sectors to grow and then creating more of a pull factor instead of a push factor that's going to result in the localization of these technologies. I think it starts with actually getting successful projects in place, having a local market, And then there would be of course, local manufacturing drive to support that. But I think we need to be very pragmatic. Yeah.
Right. No, fully agree with that. Yeah, I think with mining and beneficiation must go industrialization. So I think we've got to pick up that industrialization agenda. What's that final manufactured product that we can then offer to the global community and into the markets out there? Thank you for that. And sorry, I lost my link for a little while. I'm coming to you from Harare, Zimbabwe. So I'm here in Harare and managing the session. And we all are here because it was around 1994, Mr. Mandela came to office and he got us all to get across and make friends with our colleagues in SADC so that we could establish the Southern African Power Pool. So there we are, 1995, it was formally established, and we're now celebrating 30 years of successful interconnectivity all the way from Cape Town to Kinshasa. So all the country here and SADC is here. And I think we need to think a little bit not beyond just South Africa, but regionally and continentally, and see best how we go together. Also, in that same breath, it was Mr. Mandela that got ASSAf created, the Academy of Science. And ASSAf was established in 1996. And he had called for the Academy of Science to be the voice of the academics of South Africa, the voice of science, to be evidence-based and led arguments. And that's where we are. So I think we can come together collectively as the Academy of Science, Academy of Engineering, the intellectual capital that's in academia, in government, in policy, in industry, and come together and see best how we could give this new economy, the hydrogen economy, maximum support to go forward and to serve the nation and to serve the region and the continent in this global space of a changing environment. We've definitely got to leave all our coal behind in Mpumalanga. Those power stations that are still working and giving you electricity will have to stop working somewhere in the future. But we have to find new solutions that are environmentally friendly, climate friendly, but also economically friendly and safe and secure for all our peoples to apply. So those are the challenges we've got. And I think Mr. Mandela and President de Klerk, 1994, 1995, left us all with a tall order. And I think we can come together and help make that difference. Colleagues, I think we've exhausted the list of questions that we had on hand. And let me start to wrap up and thank our presenters, to our 4 presenters. Thank you very much. Thank you for coming and sharing your wisdom, your thoughts. I think this is just the start. We're going to come back to you, and we want to the series on the hydrogen economy and take it forward. And to the team at ASSAf and the Academy of Engineering, the admin team working in the background, thank you very much for the job that you have done in getting us all together and getting this event. All the material that was disseminated today, both the presentations and all the questions and the conversations around the questions. So, and we'll continue to build on this going forward.